Morning, good afternoon. Today, me, Rasika Vyawahare, along with Deepak Ghuge and Rahul Nema, presenting on crash consistent backup of complex containerized application with multiple PVCs. Agenda for today's topic is Introduction to Containers, Storage for Containers, Sample Containerized Application Overview, Consistency Group, Benefits, and Q&A. Containers. Containers are an operating system virtualization technology. In containers, instead of virtualizing the entire computer, only the OS is virtualized. Container sits on top of operating system and it shares the host kernel along with binaries and libraries. Those shared resources are read-only. As containers shared the resources, their size becomes exponentially light. Containers are small, fast, lightweight, and portable. Storage for containers. Every time when we deploy any application, whether it's containerized or VM based, volume is must. For containerized application, volumes can be static volumes or dynamic volumes. When we integrate any containerized orchestration engine with any third party storage provider, we can provision a dynamic volume. That volume will get created at the time of deployment. So CSI is an interface between the container workloads and third-party storage that supports the creation and configuration of persistent storage to the external orchestrator. So here is a sample application for WordPress. So if we see here, this blue box is a WordPress application, but inside this WordPress application which exists via any URL, and if it is an containerized application, we actually access the routes of this WordPress application. Whenever we want to create any blogs, we need images and we need themes and we need data. So to maintain the images and themes, WordPress has their volumes, and that volumes is being provisioned by the CSI. Maybe it is integrated with any other container storage. For example, with OCP supports ODF, and there are many such other storage providers. So for WordPress, we have a volume, and for database, which contains the actual data about your blogs and everything, it also have the volume. Database can be any database, whether it's MariaDB, MySQL. So volume will be there. So this is how the layer will get formed. Volumes will get created for WordPress and database. Then pods will get associated with that. So whenever we deploy any application, first it creates a deployment for WordPress and then for database, and for those deployments, pods will get created, pods will get attached to the volumes, and all the data which we provide for blogs, themes, images will get stored in the WordPress volume, and all data related to the contents of the blog will get stored in the database volume. Now, how this consistency group help us to take up a backup will be explained by my colleague Deepak Ghuge. Over to you, Deepak.
Hey, thanks Rasika. Hello everyone, myself Deepak Ghuge. I'm an architect and master inventor with IBM. I'm currently working on enabling spectrum scale file system as a storage for container. So Rasika explained this sample WordPress application. We will dig it a bit further. Now we know there are two volumes. One is used for images of the blogs, another for the content of the blog. Now admin takes an hourly backup of both of these volumes just to make sure that if something happens, it can revert it back to those at that instant. But to guarantee the consistency, he needs to take an backup or the snapshot at exactly same time for both of these volumes. Can he do it today? Not most likely, and this is where consistency groups comes in. So consistency groups is not a new term to the storage world. It is used quite frequently, but it is not that frequently used in the container world. it may have different usage in different context or meaning. Here I am using in the context of a group of persistent volume belonging to an application requiring consistency at any given point in past, either by snapshot or some other mechanism. Okay. Now let's take a step back. Now see, let's see what are different kind of application at a high level from consistency view in the Kubernetes or container world. So I see this as a largely three different kind of application. The first one being where you have multiple volumes, but there are no dependency between the volume for consistency. So independent kind of volume. So you don't require the consistency in this way. The second group is where you have two or more volumes where you require, if application says it is consistent, it require consistency at this two volume level. So only if these two volumes are consistent, then only application is consistent. And our sample application kind of lands in this area. Another is the complex application. Okay, these are the likely application we come across in the real lives, and this application might have multiple groups in them, and the application consistency not depend on all the consistency of all volume at the same time, but the consistency at subgroup level. Okay, now let's what happens today. What is the state as of today? So as we know, Kubernetes snapshot are independent. What it means is whenever we send a Kubernetes request, snapshot request, okay, so it might happen that even those are sent at the same exact time, those are processed at different times. Okay, which then CSI driver or storage vendor perceive as a different request or same request, but there can be problem because they're not the problem, but this is how it is. Now there are some vendor they have storage vendors, those storage vendor specific utilities for group snapshot. What happens is you have these utilities, you initiated a group snapshot, and then the snapshot of all those will happen at the same exact time. But those are the specific utilities. Now, because of these specific utilities, a backup vendor has to support some Kubernetes platform, they have to integrate with this storage vendor. So here comes the lock-in with this storage vendor. And another way to guarantee the consistency is taking the application down and then taking a snapshot. It guarantees the consistency. Or this vendor requires downtime to guarantee the consistency. Okay. Now let's see this all flow in the in this slide. Okay, these two lines represent a timeline for both of these two volume. The first volume is the WordPress volume, and second volume is the database volume. The small dot represent things are getting changed on those volumes. Okay, now assume at T0 application admin initiate the snapshot for both of these two volumes. What happens is at T1 the snapshot of database volumes gets completed. Okay, since the request is raised for both of these two volumes, at T2 the snapshot of WordPress volumes gets completed. Now what happens when the admin wants to restore the both of these two volumes? Now he refers to the snapshot that he initiated at T0. Okay, but what he will get is the content of database volume at T1 and the WordPress volume at T2. So there is likely to be inconsistency between these two volumes. Okay, this is the current regular flow of Kubernetes snapshot. What happens today? Now the major question is, now if we want to take up benefits of consistency group, the first question will be how to define a consistency group. There can be multiple ways to define a consistency group. The simple can be the namespace based consistency group. Means the PVC belonging to namespace will be part of consistency group. It means if application creates multiple PVC in one namespace and all those PVC, if we want to consistency, then take a snapshot of all those PVC at the exact same time, and that will guarantee the consistency. So PVC belonging to namespace is one way. Another way is uh, either label or annotation on PVC or other resources. Those can be used to define a consistency group. CSI driver or storage vendor backend needs to take care of the management of these labels and annotation. Another way is defining a consistency group via the storage class parameter. So you can have, since storage class, you can have a custom parameter, you can specify the consistency group name in there. But this is not optimal because it requires to create as many as storage classes, as many as of the consistency group. So this is not optimal, but it is one of the way. Now let's see how the flow will look like, or how consistency group help consistent snapshot. Now this is the same timeline like we have seen in the regular flow. We have two volumes, database volume and WordPress volume. The small dot represent the content being changed on those volumes. Now at T0, similar to the regular flow, admin initiate the snapshot for both of these volumes. Now at T1, the snapshot of database volume completed in regular flow, here also snapshot of the database volumes gets completed. But here, instead of database volume, the snapshot of consistency group is taken. Okay. Now then, still there is a request for the WordPress volume snapshot to be complete. Now at T2, the request will be processed by CSI driver or storage vendor to complete the snapshot. But at this time, what happens is the CSI driver or storage vendor plugin checks if there is a present consistency group snapshot and it is within a toleration. So question is, what is toleration? Toleration is time in minutes. For example, if you have hourly backup cycle, then you can say my toleration is say 20 minutes or less than, anything less than 1 hour. What it means is any snapshot request coming in within that time will be treated as a group request. Okay. Now at T2, what happens is you get a snapshot request for the WordPress volume. Now it checks whether there is a already snapshot for the consistency group. And if yes, there is, because at T1 there is a previous consistency group snapshot. Another check is whether it is within toleration. If yes, the T2, the storage plugin will just send that the snapshot successful, and then there is no up, and it just refer to the consistency group snapshot. Now, when admin goes and restore the snapshot he initiated at T0, what it gets is both of the content of both database volume and WordPress volume at a T1. That is at the exact same time of both content. This is how it guarantees the consistency. Now, how we achieved this? Okay, let's see how we achieved this in our CSI driver. Okay, thanks to IBM Spectrum Scale, which is the file system, and we have IBM Spectrum Scale CSI driver for the Kubernetes and OpenShift. Now there is a file system. It is a file system, so all the data, the volume data will be inside that file system. But we created a layout within that file system to support the consistency group. Okay, so there is an independent file set and then dependent file set. Consider these are just the entity or directories in the file system. Okay, these are independent file set is an entity where you can take a snapshot, and at this time file system get quiesced, and then you have consistent snapshot of all the content underneath it. Okay, so what exactly happens is when at T1, when database volume snapshot was happening, it was actually taking a snapshot of independent file set, that is XXX WordPress. And what it has the content for both WordPress volume and database volume. Okay, now when at T2, when a snapshot of WordPress was happening, it just check if it is if there is already snapshot of WordPress, uh, that is the consistency group. And if yes, and it is within a toleration time, it goes ahead and say the snapshot complete and written successfully, and just point to the WordPress application, WordPress snapshot. So this is how IBM Spectrum scale help achieve the consistency group functionality. Now, what are the benefits of this consistency group? The one major thing is there is no change in the Kubernetes snapshot flow. Okay, the admin has to create a request for all the volume snapshot. Okay, and then CSI driver takes care of grouping those together. So no change in the Kubernetes snapshot flow. Now it works with any backup and restore utilities, because since there is no change in Kubernetes snapshot flow, this backup and restore utility uses the Kubernetes snapshot, and there is a snapshot of all the volume belongings to that application at the same time. So it works with any backup and restore utilities. The snapshot are quite fast because these works on COW, copy on write. So those are fast. So it is doesn't help much of downtime, even no downtime. Okay. One question will come in mind, right? I have different requirement within application. I require for some PVC I require from faster storage, some PVC I require encryption, some PVC I require compression. So how to achieve that in the same consistency? So this works. So you can put all these PVC with different characteristics inside same consistency group, and you will get the consistent snapshot. Consistency group and many such cool features are readily available in IBM Spectrum Fusion. IBM Spectrum Fusion is a foundation for container native applications with enterprise grade data storage and protection services. So do check it out. Thank you. Also, please take a moment to read this session. Thank you.